right, so section 9.2 is over measures of variation. So when we talk about variation in statistics, we're talking about spread. We're talking about how spread out is the data from a given central point. So when we talk about spread, we're talking about two things in particular. So the first thing that we're talking about is the range of values. So between what two values does the data fall between, and how much is there between those? So to calculate range, we just take the max minus the min. That's it, the maximum value minus the minimum value. So for example, if I give you the data values 32, 41, 47, 53, and 57, they'll ask us to calculate the range, okay? So to do that, we need to know the max and we need to know the min. So the minimum value here, the smallest value, would be 32, and the maximum value, the largest value, would be 53. So to find the range, we do max minus min. So that would be 53 minus 32, which gives us 21. So therefore, the range of data values here is 21. Okay. Now, the range is nice because it does give us a large spread, but it only looks at extremes. It only looks at the min and the max. It doesn't really tell us much about how else the data is distributed between the extremes. So from there, we go on to talk about standard deviation and variance. So when we look at these two, this helps give us an idea of looking at how far out from a central tendency, from the mean per se, would these data values be spread? So here we use this idea of standard deviation and variance. To do this, we have two formulas that we use. So to calculate the variance of a sample, we use the following formula. So when we talk about variance and standard deviation, we use the Greek letter sigma to represent this value. So for variance, we call this sigma squared. Sometimes you may just see it abbreviated VAR. They're both the same thing. In your book, they use S. So to calculate variance, what we have to do is we have to find the sum of all the data values squared, subtract the number of data values times the mean squared over the number of data values minus 1. Okay, so that's variance. Then, from the variance, we can calculate standard deviation. So standard deviation, again, is sigma, and essentially, it's the square root of the variance. So we would take the square root of whatever this answer is. Okay. Now, this is the most commonly used measure of variation. It looks at the measure of the variation from the mean, so it's very particular. So, for example, you could be given the following data values: 7, 9, 18, 22, 27, 29, 32, and 40. And they'll say find the standard deviation. So the first way to find standard deviation is to manually calculate it. It can be a hassle, especially with a large group of numbers, which is why I left this one to be more manageable. So to calculate standard deviation for this given information, what I would do here is I would do a table. So in my table, I would have my x values, and then I would do x squared. So we have 7, 9, 18, 22, 27, 29, 32, and 40. Then I would list out the squares of each of those values. So 49, 81, 324, 484, 729, 841, 1024, and 1600. So then at the very bottom, I'm going to total these up. So when we total these up, we end up with 5132. Okay. Then the next step would be to find the mean of these. So when I find the mean of all 8 of these values, we end up with a mean of 23. So that's our x bar. So to calculate standard deviation, we have to calculate variance first. So we start with sigma squared. Well, we know that this is the summation of all the x values squared. So this would be 5132 minus 8 times 23 squared over 8 minus 1. So then here, when I calculate this, we end up with 5132 minus 8 times 529 over 7. And then we end up with the sigma squared. We work that out to get 128.6. Now that's the variation. We're not done yet. So the last step here is we have to calculate standard deviation by taking the square root of this. So when I take the square root, we end up with a standard deviation of approximately 11.3. So therefore, the standard deviation of this data set is 11.3. So the spread varies by 11.3 from the mean. Okay. So now with that said, when we interpret standard deviation, we look at how many standard deviations from the mean does the data set fall. And we're going to get more into that in section 9.3 when we talk about normal distributions. With that said, I'm going to go ahead and stop here for this. In the next video, we'll talk about calculating standard deviation for group distribution and then looking at quality assurance. So we'll catch you in a little bit.